Hi, I thought this time we'd go through and look at a cheapest link computation and practice that and see how that works if we're using a spreadsheet. So to start out, when I do a cheapest link circuit build, I start out by identifying the shortest edges in the graph. And the first two I can really pick anything. I'm going to highlight those in red and bold so I can see them. And then as we go along, I'm going to black out rows and columns that we've overused. So the smallest length in the entire matrix of lengths, so if I look at my weighted adjacency matrix, the 3 is the smallest number. It does appear in two places, but I'm just starting out marking the one below the diagonal. And that 3 represents the length from the vegan restaurant to the Indian restaurant. Next, I'm going to find the next shortest length in my graph, which I believe is the 8, the length from the barbecue restaurant to the pizza place. So I've labeled the barbecue restaurant and the pizza place. I'm going to go ahead and connect those because there isn't anything smaller than an 8. All right. Next, I'm still free to do anything because I don't have any edges that connect yet. So the next length I see is there's a 9, which I've now made red, and that 9 goes from the oyster house to the cafe. Then I start looking, and there are 2 different edges in my graph that are 10s. I have a 10 that goes here from the cafe to the Indian restaurant. I also have a 10 that goes from the Indian restaurant to the oyster house. So I'm going to make a choice, and I'm going to choose arbitrarily just so that my graph has less going on in the way I drew it. I'm going to choose to take the 10 from the Indian restaurant to the cafe. So here's Indian restaurant to cafe cell, and I'm going to make it red. Now that for the first time I've got several vertices that have 2 edges headed in and out of them, notice you can find them by rows, like the cafe row here. You'll see it has 2 things that are red. So I'm going to shade that row out. And then the cafe also is represented by this vertical row. I don't want to use that either, so I'm going to shade that out. And then the other one where I had 2 was the Indian restaurant. So the Indian restaurant has already been entered and exited. And so I'm going to shade out the rows and columns representing the Indian restaurant. I'm doing that to remind myself that those are edges that I can't take. Okay. Back at it. Here we go. We now have to find the next smallest length. There are some 11s. There's an 11 from the barbecue restaurant to the Thai restaurant. There's an 11 from the barbecue restaurant to the vegan restaurant. Again, this is a choice. Both of them are using the barbecue joint as one of their 2 edges, so I just need to pick. We haven't yet connected to the Thai place, so let's go ahead and finish up by using this edge that goes from the barbecue restaurant to the Thai place. So that's the 11. I've marked in here that it goes from barbecue to Thai. So I'll go over here and I'll mark that. And now I have used up the barbecue restaurant as a source of lengths. So I'm going to shade out the barbecue in its row and in its column. And part of this is so that I only look at remaining edges that are not currently in use. So what's left? Well, there's still another 12 that I see. 12 seems to be the next smallest number. There is a 12 that isn't blacked out, this Thai to the pizza cafe. Now look though what happens if I draw that edge. If I go from the Thai to the pizza, you'll notice that actually made a circuit. I don't want to do that. Let's go ahead and take that out. So now I need another edge because I cannot use the tie in the pizza. So I'm going to go ahead and black out the tie in pizza so I don't use it. It's shaded. What's left? I have a 13, a 21, a 25, a 19, and another 13. The 13 goes from the vegan to the oyster house, this 13 cell here. What would happen if I drew that one? Vegan to oyster house, that's not going to work so hot. That's going to make a circuit. Let's get rid of that. Okay, so we can't use that one. Vegan to oyster house is out. But there's another 13 in my graph, and that's oyster house to pizza cafe. That connection, if I check on my graph, I believe that one's okay. Pizza to oyster house would then go oyster to cafe, cafe to Indian, Indian to vegan. We're all right. Okay, so we can use that one. So pizza to oyster house it is. Made that red, but now I have used both ends of the pizza restaurant, so now I'm going to black out the rest of the pizza. Row and column. And what we see remaining in my graph are just two edges. There's a 19. That goes from the tie to the oyster house. Oh, but oyster house is used up, so I forgot to block something out. Oyster house is used up. Oyster house is used up. So now we can see there's really only one edge left in my graph, and it is the edge that takes us from the Thai restaurant to the vegan place. So I'll mark that in. And then I always like to check at this point that this does make a circuit. So let's assume that we actually started at the pizza place. I'm going to travel the circuit, pizza to oyster, to cafe, to Indian, to vegan, to Thai, to barbecue, back to pizza. That's going to work. Great. So I'll mark that last edge in my graph that I chose to use. And now to write in my cheapest link, I'm going to hit equals, and then I'm going to do the sum of, and I'm just going to list all of the 1, 2, 3, 4, 5, 6, 7 edges that I highlighted. So this one, comma, this one, comma, this one, this one, this one, this one, and this one. So if we look at the list up here, D8 to E8, E8 to E3, E3 to F3, F3 to F2, F2 to G2, G2 to G4, and there we go, we got a 79. Now I believe when I ran the cheapest link before and made different choices about which edges to select, I was able to get a smaller circuit length, but I'm not going to ask you to go try to find the best cheapest length, sort of checking every time there are two options. It's perfectly fine to just check one and say you followed the algorithm. I apologize for yawning. So there we go. We found a cheapest link circuit in this case.